All right, so for this particular lesson, we're going to be covering the product property and the quotient property. Okay. Um, so these are just additional properties for exponents. And, we really make it sound very serious. We actually call them the laws of exponents. So you'll hear that term a lot. And so eventually what you will do is put all of these rules together. So previous lesson was on negative exponents and using the power of zero. Anything to the zero power is 1. So now we're adding to that list, which will be the product property. Product means you're multiplying, and quotient means what? You're dividing. Okay, so this is what your foldable should look like. So we're going to go through the examples on the right. So the product property just states that when you are multiplying, what do you do with the exponents? So if you look up here, the rule says that you add the exponents together. So you keep the same base, and this is when the base is the same. So you have a base A and a base A, or you could have a base 2 and a base 2. It doesn't matter what it is, but you have the same base, and then you just simply add the exponents. Okay, so this part you should already have in your foldable. It just really gives you the rules here. Again, same base, you add the exponents. So you don't multiply the exponents. That's the key. Here, it shows you just using a base x, and then so 2 plus 3 will give you x to the 5th power. Okay, so that's just an explanation. And then it tells you why it works. So if you look at it, the reason why it works, okay, let's take a look. If I can move it. So if you have x squared, technically that means x times x. And if you have x to the 3rd power, that means x times x times x. So when you add them all together, you have 5 of them, x, 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 and x. So that's how you get x to the 5th power. So that is why, that's the concrete reason as to why you just simply add the exponents. So it's just giving you a nice visual. All right, so let's just take a look. Okay, this is pretty simple here. You have x to the 4th, and that's times x to the 3rd. You just simply add them together, and what is that going to give you? X to the 7th. Okay, so it's a simple addition. Okay, when it's multiplication. Example 2. Now you do have to keep in mind that every base has an exponent. So that's like a 1. So you always have to make sure you remember that. So when you add 2 plus 5 plus 1, that gives you a total of 8. Okay. All right, so let's move on to the next problem. So what happens if you have a number here like positive 2 and negative 6? You actually multiply those together. So that gives you negative 12, and then you actually add 5 plus 3. Same thing here. So you have those coefficients there. You have 4 times 3, and technically times 1. So that gives you 12. And then you add all of your g's together. So how many g's do I have? I have 4 plus 9 plus 3. All right, very good. So that's going to give you 12g to the 16th. All right, number 5. So again, we're still multiplying. So we have 3 times 7. That's going to give us 21. But notice this time we have y's and z's. So we can only add y's to y's and z's to z's. All right? So 3 times 7 will obviously give us 21. And then when we add our y's, we get 6. And we add our z's, we get 9. Okay? Number 6. Same process. 8 times 5 gives us 40, and we're only going to add A's to A's, B's to B's, and keep in mind there's a 1 here by this B, and then C's to C's, so there's also a 1 by the C. So you end up with 40, A to the 11th, B to the 8th, C to the 4th. Okay. All right, number 7. Well, actually, the quotient property. So we're switching gears. It's not a number 7. We're going to the quotient property. So what do you think is going to happen? So if we were adding when it was multiplication, what do you think we're going to do when it's division? Subtract is just the opposite. So here's your rule right here. Okay, so it says if, again, same base, you subtract the exponents. All right, so let's take a look. And then it just gives you an explanation again using actual variables and numbers. So if I have x to the 5th, x to the 2nd, I subtract 5 minus 2, that gives me x to the 3rd. Okay, why does that work? Okay, let's take a look. So I have x times x times x times x times x because I have 5 at the top. And then I can cross out pairs of x's. So, because an x and an x divided by an x equals to 1 whole. So when you cross out pairs, you're still left with x to the 3rd at the top. Okay, so that's why, again, this actually works, and then you just have to remember to subtract. So, very quickly, 7 minus 2, x to the 5th. Okay. Very basic. 13 minus 5, v to the 8th. Now, what happens if you put a number in front of those variables? Then all you have to do is treat them just like you would any ordinary fraction. You would reduce it just like you would normally do. So 27 divided by 9 is what? 3. And then when you subtract your k's, you get 4. So these numbers here, you do treat them just like you normally would. And let's just say you had a 10 over 6, you would just divide both numbers by 2 and reduce it like you would any ordinary fraction. Okay, they may not always divide to get a whole number. That's my point. So for here, we would reduce 6 over 30 to like 1/5. So there's like an invisible 1 here. And when I subtract my ends, I get 2. So you don't really, now obviously if you actually put the 1 there, just so you'll know it is 1/5, but if there's something at the top with it, you don't need to keep it. So you would need to really take it away because we don't write 1 as a coefficient. Okay, it's understood that it's an invisible 1 there. All right, next one. So these are simplifying to whole numbers. So 42 divided by 6 is 7. And then look, we have to subtract our f's and we subtract the g's. Now let's pay attention to what happened here. So obviously 8 minus 5 is 3. But look what happened when I did 6 minus 7. Well, 6 minus 7 is what? All right. So if I do g to the -1, remember our negative exponent rule from the other day, you have to take the reciprocal, that means put it into the denominator so it will become positive. So now we're putting that rule to this rule, these rules that we're learning today. All right? So let's take a look at this one. Okay? How would we reduce 12 over 32? Okay? Actually, that should be, let's look. This is a 12, is that a 12, right? And 32. All right, let's take a look. They might have this one incorrect. So yes, 12 over 32 will reduce to 3 over 8. And then you subtract your C's. 9 minus 4 is 5. And this should be a D. Is that correct? And then for your D, so let's just make that a D. So that should be D to the 3rd. Okay. All right, let's move on, and that's it for that. So what you're going to do for your classwork today